In our third video, we'll talk about how do we measure that electrical potential. The definition of a galvanic cell is the same thing as a voltaic cell after Voltaire, who studied this thing. It's the same thing as a battery. Okay, so these three terms can be used interchangeably. Okay, and a galvanic cell or voltaic cell or battery turns chemical potential into electrical. Okay, so the electrodes, the electrons, are actually pulled from anode to cathode. Okay, so the electrons always move from anode to cathode. Okay, that pull is called the electromotive force, or the cell potential. Electromotive force is often abbreviated as EMFs. Okay. All right. So, how do you measure this potential? Okay. Well, how do you measure a gravitational potential? If I got a rock on the top of a hill, my gravitational potential is equal to mass times gravity times height, right? You have a bigger height, you have a bigger potential. Well, where do you measure the height from? You measure the height from the bottom. So I know my height. My height is measured from the bottom. There's my zero, and up we go. But how do you measure a chemical potential? We're not, what are you measuring from when you measure a chemical potential? So once again, they have to come up with a baseline 0 point. For mountains, we measure from sea level, right? That was our arbitrary decision. So our arbitrary decision is that we say that this pull of H plus to attract electrons to form hydrogen gas has a potential of 0 volts. Okay, that's the cell potential, or the electromotive force. Okay, so this is the hydrogen cell potential. Everything is measured in comparison to that. So we just define it to be 0. Okay, it's not like it's actually 0, just like the bottom of a mountain actually isn't 0, because mountains can go below water. So the height of a mountain can actually go negative. But we define the 0 point on a mountain to be sea level. We define this reaction to be a potential of 0. Everything is compared to that. So when you look in your book, on page 845 is a list of all the different reaction cell potentials. Okay, doesn't have all the reactions, but it lists many reactions and their potentials, and you'll see the hydrogen one listed at 0. Okay, so let's measure the potential of the following battery. Okay. Oh, I forgot to mention that little circle here means standard conditions. Standard conditions is 1 atmosphere, 25 degrees Celsius, and a concentration of 1 molar. So my hydrogen ions here would have a concentration of 1 molar. Okay, so that is standard conditions. All right. So I'm going to have a battery here, and I'm going to do number 42B out of the book on page 879. They want us to calculate the cell potential and draw a picture of the following battery, okay? So all reactions are written as reductions, okay? So when I go look, so all reactions are written as reductions. And if you go to that page in the book that I mentioned, page 845, you'll see they're all written as reductions. So manganese reduced gives me a okay, and then iron also written as reduction gives me okay. Just like we talked about